Hello everyone, welcome to the second episode of the series Designing a 909 Rimshot Eurorack module. In the first episode we tested the circuit on breadboard and listened to it as well, so this is what the design looks like right now. So the next step will be to input the schematic diagram into KiCad. There are of course other tools that you can use, for example Autodesk Eagle, Altium Designer or synthdiy, but my choice is KiCad. If you don't already have KiCad installed on your computer, you will need to download it and install it. The installation process is very easy. I will not go through the process here, but there are lots of tutorials on KiCad if you need help with that. One important thing is that you will need at least version 7 of KiCad, because we are going to use a couple of features from that version when we design the front panel later on. So, after you have installed KiCad, this is what the program looks like when you start it. And this is the KiCad launcher, and what you see here are different programs that are part of the KiCad suite. And in this episode we will focus on the schematic editor, because we will do schematic capture of the design. And to begin doing that, we need to create the design first of all. And we do this by this create new blank project. And as you can see here, we have this one ticked, create a new folder for the project. And that is something I prefer to do, that I create a folder for each of my designs so I can separate them. So we will call this design 909 Rim. Save it. And now you can see that we have two documents here. The first one is the PCB design, but that is just a template, and the second one is the schematic diagram. So we will start the schematic editor, and as you can see here we have a blank drawing. And we are going to start by filling in the title section here and everything. And we do that by page settings. And it's always a good idea to, when you do a change to a schematic diagram, that you update the date. And also if you make big changes, then the revision is also good to bump to the next number. I prefer to use numbers like this, but you can use letters or combination of like numbers and letters and decimals and whatever you like. And we will call this module, we give it a title and call it 909 Rimshot. And if you like to, you can set the a company name like this. Yeah, this is not a real company, but I prefer to do it like that to show that this design is made by me. Okay, so if we start looking around in the schematic editor, we see on the left side here we have basically properties or visual, what canvas or our drawing should look like. Can turn on and off the grid and change the units and do things like that. On the upper part here we have different actions that we can do, zoom in and out, and we also have this set of tools here. I will not go into them right now, but we will use a couple of these later on in this episode. And to the right side we have different actions that we can do to this schematic. We can add symbols, we can add power nets or power symbols, we can draw wires, we can add net names, so on. We can also add graphical entities to the drawing. Okay, so let's start by adding some components. And we do that by adding a symbol. And we want to add a resistor. So we can type R, for example, and then it will show everything that has an R in it, and a simple resistor is always called like R, like so. So we choose that, and if I zoom in a little bit, then you can see at the cursor we still have the add symbol command active. So I can, by pressing that again, then I can choose a new symbol, and it defaults to the old one. So we have a second resistor. If I press escape, then I get out of that mode, and I can select the component, and I can use Ctrl+C and Ctrl+V to add a copy. So that is also something that we are going to do a lot. So we have 3 resistors right now, and we would like to have a capacitor. So let's add that. We type C in the search bar here, and then we see the symbol of the capacitor, and we can add that, and we want to orient it like this instead. So I can use the R key here to rotate the component. Okay, here we have our capacitor, and we can add a diode. And in this case, I know that I want to have the 1N4148. So I type 4148, and under diode here we have what we are looking for. So this is a true hole version of the diode, but I want to use the SMT version, so I choose this one instead, and then you can see we have the footprint of the surface mount symbol here. Okay, so let's add that, and we want to orient it the other way, like so. Okay, so we would like to have one of these resistors and use them as to pull down. So, and if I select the symbol and just use the mouse to drag it like this, then I can move it, and we can zoom in. I'm using the mouse wheel to zoom in and zoom out, but I also have these buttons here. This is zoom to fit, so you can see the complete diagram. All right, so let's zoom in a little bit, and we want to add a ground connection, and we can do that by selecting. Now we have I've already typed GND at some point, so it remembers that. And now I can choose this one, and we have the GND. All right, as you can see, the symbols, they have round circles at the ends, and that means that this circle means that it's unconnected. So if I take this symbol and drag it onto here, it disappears. That means that these two are now connected to each other. However, I prefer, this is personally, I don't like to connect components onto other components like this. I prefer to have a small stub of wire between it. So, and if we now drag this symbol, then you can see that there is a green line showing up, and that is a wire. So that is one way of doing it. And now you can see that this is a little bit more symmetric than it was before, when the GND symbol was up here. And if you want to add a wire to an unconnected component, we just place the cursor above the unconnected end or connection is maybe the right word, and then you see that the cursor changes to a pen. So this means that I can draw a wire now. So we will do that. I will start up here like so, and then I will connect these two, and the blob you see here, that is a junction. that means that this wire is connected to this wire. So there are an electrical connection between all these three components. All right, so we have started on the trig input circuit, and the next step I think would be to add an input jack. And we can do that by typing audio jack like this, and this looks almost correct, but we are actually missing one. We are missing the switch to the tip here, but there is a symbol for that, and this is the one that I'm using. And here we have the symbol for the jack, and you can see that it has all the three connections with a switch and the tip and the sleeve. So the sleeve will be connected to ground, so I will rotate it like this, but now it's turned the wrong way, so I want to flip it. And there are two keys on the keyboard that you can use for that. One is the X key, which flips it like this, and the other one is the Y key. So the Y key, sorry, the X key was the correct one to use here. All right, and now I just want to align it a little bit here, so I can connect it properly and move it to the left side. I prefer to have input signals or input jacks on the left side and output jacks on the right side. But that is my personal preference, because I've been drawing schematics like that all my life, so that's why I'm doing it. But you can of course choose whatever way you want to do it. All right, so we want to tidy up the properties a little bit. Those green texts that you see here, those are called properties. So we are going to move them like this and like this. And by selecting the property and hitting the E key, you can edit the property. And in this case, I want to call it trig in. Trig underscore in. I'm not using space here. I use underscore instead, just to keep it as one word. All right. So we have one input jack fixed already, and I think the next step is to add some more components. So let's do that. Let's add a TL-072 op-amp. And if you look at this symbol, you see that there are sort of three units, unit A, B, C, and these are the different op-amps in the same IC. So here we have the first one, there we have the second one, you see that the pin numbers changed, and the third one is the power pins, so that's a separate symbol. But if you choose this one, then we can place it on the schematic diagram like this, and we will put the second one here, and then we have the power connections, and I put them down here for now. All right, so that was op-amps. We will also need some transistors. So we will add those. And the design by Hex Inverter uses BC549. As you can see, these are TU92 through-hole components. But I want to use an SMT version. So I choose this one, BC849. And as you can see, it has now changed to SOT 23, which is the SMT component. Okay, so we will need 2 of those, I think. One here and one away here somewhere. And we will also need a PMP version of this. So we can type it like that. You see that I'm using the search field here a lot, and if you know what component you are looking for, it's always easier to use this. But if you want to browse around, let's say that you want to choose a transistor, you don't know what it's called, but you know that it's transistor BJT, for example, then you can go down to transistor BJT, and then you can start choosing which one you want to have. So you can sort of browse, if you don't know exactly what you're looking for, then you can browse for a specific component that you think, this looks like the one I'm looking for. But if you already know what you are looking for, in that case you can type it in. It's always quicker to do that. All right. So I think we have all the transistors that we need for now. All right. Next we need a potentiometer. So let's get that. Like so. And we will also need a power jack. See if we can find one. We will try to browse after this. What we are looking for is something like this. This one. So we will use a 10-pin power connector. So I always use this type of connector for that. Right, we'll put that at the bottom. And I think the last thing we need is 2 electrolytic capacitors. And I have to type that because this one. That's the one that I'm using normally. Okay, and we need 2 of those. All right. So one word about the power connector. We will move this over here, and that is the side with the marking, the pin 1 marking. That is minus 12 volt, and so these are the pin 1 and pin 2 here. And pin 9 and 10, they are used for plus 12 volts, and the ones in the middle are ground. So we will actually need to rotate this like this. And after that we can add the power nets. And we will need 12 volts plus. And we want to use minus 12 volts as well. And I always orient them like this, so the positive is pointing upwards and the negative is pointing downwards. So yeah, it makes sense to have it like that, I think. All right, so we want to connect this like so. Take a copy of that. And we try to make it as symmetric as possible. Like this. And we will call this power. And we put the next one here. All right. Okay, so now I think I have most of it connected. We need a ground. Okay, so now I have added all the different component types that I will need in this design. So the next step is actually to start drawing the schematic diagram, and I will reuse everything here, make copies of it, and build up the schematic doing that. So, but that is something that I have already shown you, so I will only skip through this part very quickly. Okay, so now I have completed the drawing and captured basically the design. But what we are missing now is that we don't have any real values on the components. So what I will do next is to set that. And to do so, I select or hover above the R here, for example. Press E, and then I can edit it. And I will enter the component value, in this case 100K. And we do the same for this capacitor. Press E, and it should be 100 picofarad. And you can see here that it's colliding with the resistor. So what you can do here is to move it manually, or you can, in this case, flip it using the X key, like so. All right, so before I continue to do the rest of the component values, I want to mention a couple of things. And you can see here on the connector, there is an X on that connection. And that is something that you do if you have an unconnected pin and you want to tell that this is okay, this should be unconnected. Then you can use this X symbol. Otherwise you will get an error or a warning when you do the design rule check, which we are going to do later on in this episode. All right, another thing that is worth mentioning, I think, are these flags that I'm using here. These are net names. That means that everything that has the same name will be connected. So this trig output here will go into the trig inputs on the op amps. And the same way this env from the envelope generator, this will be connected over here. And you do that because if you don't want to draw long lines back and forth over the schematic diagram, then you can use net names instead, because it makes the schematic diagram look a little bit more tidy. Let's move on with setting all the component values. So the next step here is to do something about the question marks here. As you can see on the reference designators, this is a property in the component. And this property needs to be set to something. And there is actually a tool for doing that. Set reference designators. And we are going to let it do it automatically for us. So let's do this. Okay, completed without any warnings or errors. That's good. And now we can see that we have proper reference designators for the components. And let's make a quick sanity check here just to check that everything seems right. It's always a good idea to check connectors, like our jacks are J1, J2 and J4, and the power connector is J3, and that is perfectly fine with me. Then we can check the power supplies for the op amps, and we see that the op amps are called U1, U2 and U3. So that's okay. And let's check how the op amps are distributed in between the ICs. And these two, they are in the same IC, so that's okay. Here it looks a little bit funny. So we are using, that is in the second, that is in the third. And this is totally wrong, I see. Because this is U4, we don't have a power pins for that, and U5. And the reason why it became like this is because I copied this op amp 4 times. So it's used the same op amp for the rest of the design, and that is not correct. So I will fix that, and I think these two could go together. So I will delete that, take a copy of that, and add it instead. Check that the plus and minus is correct. This is a very common mistake if you for example, have an op-amp that is flipped and then you copy from somewhere else and put it there, and if you forget to flip it, then yeah, you can figure out the rest yourself. All right, so we want to replace this one as well and keep these two in the same IC. So we will do that. And here you see you have to flip this one. Like so. Then we can, then we can put it in place like that. And we can also fix this so it looks a little bit nicer. Okay, so yeah, I think we're ready for a new try. And we want to reset to start all over again. All right, now you can see that it did something here with op-amps. So let's check the connectors again. Everything seems okay. And now we have these two in the same IC. We have these two in the same IC. And these two are in the third one. All right, so I think we are done with this. We can save the design. And now we can move on to the next step, and that is the design rule check. And the design rule check is something that you do to basically double check that you haven't missed anything, or if there is any problems with your design, you have double names or net names are not matching up, or you're using, yeah, it can be anything that is that is wrong with the design that the design rule check can detect. So let's run that to see what happens. And we have 0 warnings, but we have 3 errors. And it complains about input power pin is not driven by any output power pin. And we can see here there are a couple of arrows here that point out where the problem is. All right, so what's going on here? These are the power connections to the ICs, and they are inputs. So basically this is telling me that the IC expects to receive power on this pin. And there is actually nothing in this design that is driving, that is a power output. And that is because we are receiving power from this connector. And KiCad doesn't really know if this connector is an input or an output. So we have to help KiCad with that. And the way you do that is by adding something that is called a power flag. And you can see I've already looked it up here. And what this does is that it changes the property of the net. So the net will become a power output. So we will use one of those. And add it like so. And we will add another one on the ground. Okay, then we will connect them. All right, so now we have told KiCad that these nets that comes from this connector are power outputs. All right, save the design. It's always good to do that now and then. And then we will perform the check again, and we will delete all markers and run it. And now we have no errors. So that's good. All right, so it seems that we have done the first part of the design, and the next thing we will move into is actually to start assigning footprints. All right, that's enough for today, I think. See you again in the next episode, where we will talk a little about the Eurorack form factor, and we will do the PCB layout of our design. Thank you for watching. Bye for now.